Let's go ahead and take a quick look. I'm going to get attendance while you check those. Did we already check them? We did not. So I've got you and the CP class have now actually gotten to the point where you guys are almost together. So it's much more difficult for me to keep everything straight right now. Yeah, it's so close, like maybe like 15 minutes apart. Dun, 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 dun. Any questions on that? Remember, H's have a +1 charge. That means that if you have a -2 anion, then you need to make sure that you have 2 H's. My name. Da, da, da.
Sorry, Mr. Jackson, I'm here. I didn't realize like the schedule thing. I like read it wrong.
No worries, it's fine. I haven't taken attendance yet. I got you. I got you. Yeah, my period 2 really used that schedule to they were like, oh yeah, we didn't know anything. Like they didn't show up until like 10 minutes before or 10 minutes after. They were about it. All right, let's see. We got Tegan here. Ian is there. Brayden. Gavin. Olivia and Peter. And the home players. Let's see. Let's bring up the participant list. So many. Switch to first name. Allison, Blake. Yeah, right. Yeah, Cloud. Other Gavin is here. Weston, did you get Returnal?
I did. I really like the game. It's fun.
You like what?
Returnal.
Yeah, you like it. It's fun.
Yeah, it's hard though, but I'm starting to kind of get the hang of it. So.
Harder than Demon's Souls.
I didn't play that game, but I think it's kind of the same. You have to dodge a whole bunch of stuff. But
are you looking forward to the village? Is it an the vampire werewolf like a like?
Yeah, I haven't seen that one. I'll have to check it out.
It's had a playable demo the last 2 weekends. Missing out. We got the Buckleys. All right, let's switch to the back side. Boom. All right, that looks good. Attendance looks good. Are there any AP classes that are going to interfere with this, or any AP tests? You guys have any coming up that's going to interfere with this next week? Yeah. One.
Pretty sure A push is at the same time as 9th period.
9th period gets screwed. Which day is that
I
one?
had AP art one at 12, but mine got rescheduled to June, so I don't know.
Wow. Margaret says you're not here today, but you are, right?
I am here.
Isn't AP art you just turn in the portfolio though?
No, AP art history.
Oh, okay, never mind.
All right, then. 9th period will be a little bit under fire. The reason I asked that is because I was thinking about something for Monday. Monday is going to have to be an actual lesson that I give you a recording of. And I know that was kind of the problem with some of you guys with the test, because that solubility, the KSP problems and stuff, that lesson was on a Monday. And I think that some of you guys maybe didn't take as much, pay as much attention to it or something like that. But this Monday, basically what I hope to do is to discuss the laboratory, the last thing we're doing Wednesday, Thursday, and possibly Friday if they can't get through it, is what's called the titration lab. If you ask anybody if they did high school chemistry, they remember two things. They remember something about a mole, and they remember the thing that turns pink. And then they usually do this with their hand, which shows me that they're talking about a burette, which is a piece of equipment, right? So those are like the two major things that, unless you went into, you know, science or whatnot in college, that people remember about chemistry in high school. All right, so that is what we want to do for the last thing. And yeah, this bottom one. Oh, help me out. Where is it? A sodium bicarbonate. You could also call that sodium hydrogen carbonate. Bi is another way to call it hydrogen. It is bicarbonate is on our periodic table as hydrogen carbonate. So if you had sodium hydrogen carbonate, you would be good. That will not work. It should be that bicarbonate. That's baking soda, and that is not an acid. It's a what? It's a base. You might be asking yourself, well, how's that a base? I don't see OH. You know it's a base because you found the pH of it yesterday, right? We may get to that today. We'll see. It is a base though, right? So we need to see how that works, and then maybe we'll get to that today. But before we do that, we've got some math that we need to get done from the laboratory, right? We need to fill out some of those other columns. So we know the Arrhenius concept of an acid and base. The Arrhenius idea is that acids give off H's. Easy enough. We know that when an H comes into contact with H2O, it creates what's known as the hydronium ion, H3O. The charge of that is plus because this is neutral and we add a plus to it. So it's H3O plus. That's a hydronium polyatomic ion. What I'm going to do is I'm going to say that the hydrogen ion and the hydronium ion, those concentrations are equal. I usually use H plus. That saves me from writing H3. It may not seem like a lot, but you know how many times I would have had to write H3 in my lifetime? Quite a bit, right? So we will take these two terms to mean the same thing. Hydronium and hydrogen ion, same thing. Now, to find the pH, you take the negative log of the hydrogen ion concentration. For a strong acid, like something like HCl, let's say we have 0.100 molar HCl. It's a strong acid. So that means that it dissociates completely. That means that that is the same thing as saying the hydrogen ion concentration is 0.100 molar H plus. Because it dissociates completely, leaving the H pluses to be in the solution. So how would I find the constant of the pH of that? Well, we take the negative log of 0.1, what do we get? Right? You can do it in the calculator. Negative log 0.1, we get 1. Or if you know your math, pH equals 1. If you know your math, this is actually 1 times 10 to the what? Negative first. Oh, that's right where my picture is, isn't it? That is 1 times 10 to the negative first. Well, if we negative that negative first, we get 1. And you guys know, do you know logs? Right? So the log of this would be -1, but we're taking the negative log of it. So that becomes 1. Or you can just use a calculator. As we said, strong acids, they undergo 100% ionization. for any practical purpose, the prepared concentration or the molarity of the acid for a strong acid would be the same or equal to the molarity of the hydrogen or hydronium ion. With an exception, sulfuric acid. Why is sulfuric's hydrogen ion concentration greater than the molarity of the acid alone? What's the formula for sulfuric acid? These are the kind of questions that are going to be on the last test. Nope. Sulfuric acid. We know the first element is going to be a what? No. It's an acid, so the first element has to be a what? H. What is the formula for sulfuric acid? H2S.
H2 SO4.
Good. H2SO4. So if sulfuric acid is H2SO4, why would the concentration of the acid, why would the hydrogen ion concentration be greater than the concentration of the acid for sulfuric acid? Right? So if we had hydrochloric acid, we said that 0.100 molar HCl would be like saying 0.100 molar of hydrogen ions. If I had 0.100 molar H2SO4, why would this not be 0.100 molar of H plus? Why would it be greater than this? Because we have more than one H. It's diprotic. The fact that we have more than one H here means that, yeah, we can lose this one H, and that would be the 0.100 molar, but we could also lose another H. So this is not equal to that. It's actually greater. Weak acids. Well, weak acids, we know there's only a fraction that undergoes ionization. For example, if we take a weak acid like HCN, whenever it is added to water, we get Cn negative plus H3O plus. What are the products? Right? So products go on top. Oops, negative there. And reactants go on bottom. H2O is a liquid, so what do we do? One, right? So if we take a look, here is the H3O plus. What do I want to do? I take and multiply both sides, the Ka and this side by HCN, which is the concentration of the acid, right? That's the Ma. It cancels here. Well, for every one of these, how many do I get of these? For every one CN, how many H3Os do I get? One. So that means that these two are the same concentration. So if we call this X, or just call this H3O, we could have X times X is X squared equals the molarity times the constant. And how would we solve for the X or the H3O plus? We need to take the what of both sides? Square root. That's how you get this formula. Because I multiplied both sides by it, and that is the Ma. That's the concentration of the acid, right? Or up here, it's abbreviated molarity of the acid. Molarity is a concentration. So that's how this formula was made, by using the equilibrium stuff we learned last unit. Up to you, you can memorize this formula, or you can use this formula and then rearrange it. totally up to you.
So it's really just the square root of the products?
It's the square root of the constant times the concentration of the reactants, actually. That equals the hydrogen ion concentration. When it comes to acids and bases, you don't care about this salt because that, or this anion right here, you don't care about that because that's going to be a spectator ion. So that's why, even though we have to consider it when we square it, because we're getting X, we're getting one of these, right? We don't worry about it whenever we actually talk about the acid itself, because all an acid is a way of delivering H's.
Okay, so the MA would be HCN, right? Molarity of
That would be the
HCN.
concentration of the acid, yep.
Okay, so in this case, we'd be multiplying that by the CnH3O over HCN.
Well, we have we have to have the equilibrium constant of the acid as well. So we multiply the equilibrium constant of the acid multiplied by the concentration of the hydrocyanic acid, the HCN, right? And that would be equal to the CN times the H3O. But we don't really care about this, but this would be X and this would be X. So if we want to find this, we actually have to have X squared mathematically. But to find the X, we would then take the square root of this, because most of the time you're given these two things, but you're not given the H3O.
Okay, thank you.
Yep, it'll make a lot more sense, I think, when we start doing a problem with it. Because I mean, this sounds very difficult, but it's like a lot of the other things that we do. Once you see it in action, it's just like, oh, you just multiply them and then take the square root. Yeah, there's a lot more going on underneath, and the better understanding you can do of that, obviously, the better. But it's not necessary to plug a number in and get it another one out of the calculator. So Arrhenius bases, we said, they produce hydroxides. There is something called the POH, and basically that's the same thing. It's the negative log of the hydroxide ion concentration. A strong base, which undergoes complete dissociation, that's how we'll find it. The concentration of the hydroxide or of the base is the hydroxide. For example, NaOH, whatever the concentration of NaOH is, that's equal to the concentration of OH negative, because it all dissolves to completion. For bases, it is safe to say for strong bases, OH is equal to the MB. Weak bases, we got to do the same thing. We take the base equilibrium constant multiplied by the concentration of the base or the molarity of the base, square root it, and that is the OH. And it's the same reason as this up here. NaOH yields Na plus OH negative. The Kb is equal to the products over the reactants. We're going to multiply this. This is the MB. We're going to multiply this by both sides. We don't care about this time. We don't care about the sodium this time. But X squared again, right? That will be equal to X squared. So what do we do to find X? We take the square root of it. So the hydroxide ion concentration is equal to the square root of sodium hydroxide times Kb. So this is a strong one. So you have complete ionization, right? So the Kb for the strong one would be very strong. We wouldn't have to use this because the Kb would be huge. This is ionization, whenever you have something and then it breaks down into the ions. But we wouldn't use it, the NaOH, we wouldn't have to use this because it's strong. So whatever the concentration of the NaOH is, would be equal to the OH for this, because you have like almost 100% ionization. Let's put another weak one here. Actually, we can do it later. You have them memorized? The 6 acids are strong and the 6 bases that are strong. Right? And here. Yep. Rest of them you'll have a Ka or a Kb. Now water self-ionizes. So if we take a look, we have H2O plus H2O. That will yield H3O plus OH negative. But take a look. For every H3O in pure water, you will have one OH negative. So they will cancel each other out. So the water equilibrium constant just so happens to be 1 times 10 to the negative 14. So if you multiply the concentration of hydrogen ions and the concentration of hydroxide ions, you will get this 1 times 10 to the negative 14. Well, if you have an acid, you will have more of these H3O pluses and less of these OH negatives in the acid, right? Because any OH negative would be attacked by an H3O plus to form H2O. So as this concentration goes up, this concentration goes down. Well, guess what? At any time, if you know the concentration of one of these, you can find the other by using this formula. So in water, H3O plus is equal to 1 times 10 to the negative 7th. What is the negative log of 1 times 10 to the negative 7th? Who teaches you guys logs? This last year or something?
Yeah.
What does the log do? It takes out the 1 times 10. So we get what? Negative 7. What does the negative in front of the negative log do? Changes the negative 7 to a positive 7. So what is the negative log of 1 times 10 to the negative 7? 7. And that makes sense because the pH of water is 7. I just think it's not something you practice much, right? Yeah, right. And now all of a sudden, you know, you're in probability now, right? Yeah. So if I roll a D6 and a D8, how many different ways could or how many? What's my percentage of chance of getting 9? No. Everybody at home get that? We're gonna go over it again. So let's do the POH. So the POH is the negative log of the OH concentration. What is the POH? It is also 7, which is kind of cool. If the pH equals 7, right? And the POH equals 7, we add them together and we get 14. So if you know the pH, you can find the POH by taking 14 minus the pH. Or if you know the POH, you can find the pH by taking 14 minus the POH. Right? If the pH is less than 7, what type of chemical is it? It is an acid. If the pH is greater than 7, it is a base. Well, guess what happens with the POH? If the POH is less than 7, it is a base. And if the POH is greater than 7, it is an acid. Imagine the pH is 1. That's an acid. Well, what is the POH going to be of that same chemical? A base? No, it's still an acid. It doesn't change it if we just go from pH to POH. If the pH is 1, what is the POH? Nope. 13. Because if you take 14 minus the pH, you get the POH. Right. So here are the four equations we've been using today. The negative log of the hydrogen ion concentration equals the pH. The negative log of the hydroxide ion concentration equals the POH. Hydrogen ion concentration times the hydroxide ion concentration equals 1 times 10 to the negative 14. And the pH plus the POH equals 14.
Wait, so
But it's POH. Yeah, that's an acid. Yep. Good. Just because you say, oh, I want to talk about the POH of this chemical, it doesn't change the chemical, right? It's still the same chemical. So if I say I have HCl that has a pH of 1, its POH is going to be 13. 14. Yep. So if you like, what do they call them? What is it if you're a visual learner? If you're a visual learner, maybe this pH four-corner diagram will help you, because I can go from one thing to any other thing on here. You have pH on your laboratory. They want you to find the hydrogen ion concentration on your laboratory. So if we take the antilog of the negative pH, that's the mathematical reversal of the negative log of the hydrogen ion concentration. So this is the button that I told you to never use earlier in the year. Now we're going to use it. It's the second function of the log button. That's known as the antilog. So let's say that we have -3. Our pH is 3, right? We're going to take 10 to the -3rd. Boom. We get 10 to the -3rd, or if you have it in regular notation, 0.001. So if I had a concentration of 0.001 molar HCl, its pH would be 3. Right? Why did they do that? Because it's easier to talk about something having a pH of 3 or 2 or 1 versus saying it's a 0.0001 molar solution. What is the only thing we're talking about? We're only talking about the hydrogens. So if I say I got a 0.0001 molar hydrochloric acid solution, the only thing I care about is the hydrogen, right? It's the same thing if I had a 0.001 molar nitric acid solution, the only thing I care about is the hydrogen. So basically what they did is they took these, you can have like a 0.00000 whatever, right? Concentration. They took all these different concentrations and they say, okay, let's take the negative log of them. We'll get an integer, and that integer will be between 0 and 14. It's much easier to make use of that scale than it is for everybody to sit here talking about 0.000 whatever, right? Man by the name of Soren Sorensen. Like, that's like me being called Jackson Jackson, which I think would be pretty cool. Who? Jackson Jackson? I'm sure that everybody would end up calling me JJ. They do anyway with Jason Jackson, but Soren Sorensen, I don't think anybody called him SS because, right? Not a good way to be back then. Like, yeah, yeah, right. Soren Sorensen, but he's got that cool O that has the line to it in his name.
Oh.
Yeah. And that's the thing. Yeah, if they give you the concentration of the acid, we've shown here that if it's a strong acid, you can find the pH. Or if it's a weak acid, you can find the concentration of the hydrogen ion concentration, which then you can find the pH. I don't think we need to. I think you might be complicating it. But we can do one like I think you need to do. All right, so here's the four-corner diagram. Let's take a look. Some of these you'll be able to do in your head. And you should be able to. I mean, I get it, logs are weird, or maybe, I don't know, but I mean, it's been a while since you've done them, but what is the log of 1 times 10 to the -6? It would be -6, right? Well, what do? We don't just do the log of it, we do the negative log of 1 times 10 to the -6. So it would just be, what's the -6? 6, right? So it'd be 6. Because this is the hydrogen ion concentration and they're asking for the pH. It's the hydrogen ion concentration. It doesn't matter if it's strong or weak. They've already done the hard work. Because it is the hydrogen ion concentration. This one? 3. Right? Are these acids or bases or one of each? They're both acids because we are in what realm? We are in the realm of the pH. 2.2 times 10 to the negative fourth. Can somebody tell me what it's close to? What is this pH going to be close to? It's going to be close to 4, but it's going to be less than 4. It's going to be 3 point something, right? It's always going to be like, if you have a number here, that ends up making it less than that exponent. So we know it's going to be 3 point something. That's great. We're looking forward to that, but you still need to go ahead and type negative log 2.2 times 10 to the negative 4. And there it is, 3.66, right? That's what we were expecting, 3 point something. 3.66, acid or base? Acid. 7.8 times 10 to the negative 12. What's the pH going to be close to? No, yeah, but what? It's always what? It's always one lower. So it's going to be 11 point something, right? Not 11.00, I don't think. It's going to be really high. Like, let's do it. Negative log 7.8 times 10 to the negative 12th. What's up? Yeah, there we go. Really close to 11 because this number is very close to 10. That means that we're going to be really close to 11, 11.10. pHs always go out 2 decimal places. So in reality, this would be 3.0. This would be 6.0. Here it says determine the pH if the hydrogen or hydroxide ion concentration is this. So that means that if I take the negative log of this, what will I get? 11. That is the POH. So what was the pH then? So then I take 14 minus the 11 and I get 3, acid or base? Acid, because the pH is less than 7. This gets really, I mean, this branches out into a bunch of different reps really quickly. What is the question?
So why did you get the feeling for that?
Because here I was given the hydrogen ion concentration, and here I was given the hydroxide ion concentration. And that's the big thing, right? Let's try this one. What is the POH going to be about? You keep saying the number here, but we've said many, many times. It should be how many? It should be 1 less than that. It's going to be 2 point something. You're doing this on purpose. Huh? Whatever. You guys have been doing logs for over a year now. Yeah, right. 2
Would
point.
it be 11 point? Oh, never mind.
You're right. You are correct. It's going to be 2.37, but that is equal to the POH. So what do we need to do now? 14 minus that, and we get 11.63. Good job. Who was that? Is it Coco?
On Zoom, yeah.
Good. Yes. What would this be? 11.63 pH? Base. So then we are to determine the POH if the hydroxide ion concentration is this. So now instead of giving a symbol, we've got a word. What is the hydroxide? OH negative, right? So what do we have to do to this to get the POH? Negative log it. What's it going to be about? Six something. This is small, so is it going to be close to 6 or closer to 7? Closer to 7. Log. Just trying to help you guys remember what you learned about logs, right? This also helps you do your What do you call that in math? Do you guys call it like execute, compute, evaluate? You guys have something like that? No? ECE? ECE, execute, operations, compute, evaluate. This will help you evaluate these. Oh, they did that, like, that's the teachers and like, it's more military in the, determine the POH if the pH is 1. 13, is this an acid or a base? Right, yeah, it gets hard, doesn't it? Yeah, they're like, wait, it's 13 though. Yeah, but that's the POH, right? You have to have repeat. This is repetitive. You have to do it many times. Otherwise, you just like, 14 minus 1 is 13, but 13 is the POH. So it's an acid. And if you have trouble with that, just always change it to pH. And I hate POH, right? Just don't even worry about it. If it asks for the POH, that's one thing. But then if it asks the acid or base after, look back at the pH. Then they have, okay, this is actually what you're going to do today for the laboratory. I want to get you guys into those groups pretty soon. We're trying to find this is actually the opposite, because you will have the pH, and you know that 10 to the negative pH equals the hydrogen ion concentration. And then you will need to use the formula 1 times 10 to the negative 14th divided by the hydrogen ion concentration equals the hydroxide ion concentration. For this, though, we are actually given the hydroxide ion concentration, and we are trying to find the hydrogen ion concentration. So if this is the hydroxide ion concentration, what is 1 times 10 to the negative 14 divided by 1 times 10 to the negative 12? 1 times 10 to the negative.
So that's this is
This is the hydroxide ion concentration. So what is the hydrogen ion concentration? We take 1 times 10 to the negative 14 divided by 1 times 10 to the negative 12. Just switch these. And then it will give us the hydrogen ion concentration. So what is 1 times 10 to the negative 12 divided by 1 times 10 to the negative, I'm sorry, 1 times 10 to the negative 14 divided by 1 times 10 to the 12, negative 12.
Wait, can you say it again? I'm sorry, I got.
Yeah,
What about the-
wrong. Yeah. You guys in math?
Yes, we don't do scientific notation.
All you do is take these exponents and find the difference, right?
So 1 times 10 to the negative 7.
Yeah. How else could you do that? I bet this is the way Hudson thinks. Hudson's probably like, all right, let's see. Well, the POH of that's 12, so that would make the pH what? 2. And if I take 10 to the negative pH, then we get 1 times 10 to the negative 2. It is so cyclic, right? Cyclic. Or is that Ian talking? I never talked to you. Right there. So 2.4 times 10 to the negative 6th. This one probably can't do in our head. So we take 1 times 10 to the negative 14th divided by 2.4 times 10 to the negative 6th. What should my exponent be about? Exponent should be negative 9, right? So if we take a look, 5 times 10 to the negative 9th.
Where did you get that 14 from?
Oh, that's a little something called a water equilibrium constant. We got it from right here. The hydrogen ion concentration times the hydroxide ion concentration equals 1 times 10 to the negative 14th.
Okay, sorry, I forgot about that. Thank
No
you.
worries. I mean, yeah, this is 4 equations that are basically a revolving circle, right? So I mean, I get it. But that's kind of what I'm trying to prove to you guys is that this is one of those things that once you do it enough times, it's really easy. But if you never do the practice and you just watch, it looks easy, but you know, you need the practice on this.
Why aren't we just the divided?
Where's the two at?
It's in the first group, 1.7 divided by 8.
That equals not 2. Sorry about that. Don't you know that's how I meant my equal sign? And then down here, welcome to the jungle, because they give you a bunch of stuff, different stuff, and they say, hey, give me the pH, given all this different junk, tell me whether it's acid, base, or neutral. Hey, give me the hydrogen ion concentration, given all this different junk. Hey, give me this, given all this different junk. Page 7 and 6 for tomorrow. I'll pop the answers up when we get in. What I'd like for you to do now is I'll open up some breakout rooms, and you guys can work on the 2 columns from the laboratory. You're going to use those 2 formulas that we just covered. The anti-log of the negative pH will give you the hydrogen ion concentration. And then 1 times 10 to the negative 14th divided by that hydrogen ion concentration will give you the hydroxide ion concentration. Right? Those 2 columns on the laboratory. Does this seem overwhelming? You guys, yeah. The home people have never been by it.
I'm confused on what numbers we use. Like, there's 3 columns. So
Which one is the most accurate?
is it the pH meter?
The pH meter, yes. I'm going to stop recording.